In this video, we are going to study concept of step response. As we know that we have an LTI system. This system has the transfer function h and it produces certain output. Now, what is step response? So, step response is the output of a system if we apply this system with input unit step denoted by u of t. So, if we apply u of t as the input of a system, we get the output of a system as s of t called as step response. This s of t is given as u of t convolving with the impulse response of system h of t. Now, we will simplify this equation and find out this equation for the s of t. To derive it, we know that in convolution we can interchange u and h, so it can be written as h of t convolving with u of t. So it can be represented in the equation form integration minus infinity to plus infinity h of tau into h of tau into u of t minus tau d tau. Now here unit step function is folded and shifted by amount t. Therefore, if we find out the exact position of this u of t, it can be drawn as u of t is folded, so it will be folded on the negative axis and then shifted by plus t, so it will be shifted in the negative direction by amount t. So if you substitute these limits in this equation, we get s of t equal to integration from minus infinity to plus infinity h of tau into u of tau is 1 because its amplitude is always 1 d tau, but because of this unit step signal, this integration limits are going to be updated and these limits will change from minus infinity to plus infinity will be changed from minus infinity to t because this u of t signal starts at minus infinity and ends at t. So this integration will exist only for these limits, which is called as the equation for step response. Similarly, if we want to obtain step response for a discrete signal, we have s of n is equal to summation k equal to minus infinity to n h of n. So these both equations states that if we want to find out step response of a system, provided we have given with the impulse response, then we need to simply integrate the impulse response of a system with the limits minus infinity to t and we will get the step response. Now if you want to do it in the reverse way, if step response is given and impulse response is to be obtained, we will have h of t equal to d by dt of s of t. Okay, so to remove this integration in this equation, we need to differentiate both the sides. So we get this differentiation of s of t, and if we differentiate it, we get h of t. Similarly, if we want this h of n from s of n, the simplest equation or after simplification we get h of n is equal to s of n minus s of n minus 1. So these are again two important equations to derive impulse response from step. In above two equations, s of t and s of n, we have obtained step response from impulse response. And in the last two equations, h of t, h of n, here we have obtained impulse response from the step response.